Okay, now, when we met last, we talked about the unit circle, and we said there are certain things that happen on your unit circle. That your radius of any angle that you open up like this, your radius is 1. And then we put our special triangles on there, for instance. So say we did your 45, 45. We had to convert your 45, 45 to make a radius of 1, so that the sides came out to be 1 over radical 2. Now, this is your x value. This is your y value. We said x, y, cosine, sine. Because if we put your cosine, x over r, and your r is 1, it's the same as your x value. This homework was all on your unit circle. Look how these numbers are less than 1. So when you do this, this is your x, this is your y, this is your cosine, this is your sine. So you automatically get this one. Your tangent, we did y over x. And it wasn't bad having a fraction because we change to multiply, and we flip this guy over. And this is going to come out. Just don't lose your negative sign. These are reciprocals down here. So just take these and flip them over. Take its reciprocal down here. That's all you had to do. On the unit circle, your x is your cosine, your y is your sine, because your radius is 1. Even if you went through and you put this over 1, it still comes out to be itself. If you don't have this, make sure you're understanding this. Now, it doesn't matter what quadrant you're in. And if you remember, I always say, make an information box. Make this information box. Once you put your negatives and positives there, you don't have to go through and say, all students take calculus, chemistry, however you remembered it. You don't have to say, oh, all are positive, only sine is positive, only cosine, tangent is positive. You don't have to go through and do that. It's right there. You pull out your positives and negatives right there. This guy is in quadrant 1. All your pieces are positive in quadrant 1. Your cosine is your x value. Your sine is your y value. Your tangent is probably the only one that needed work. Your cosine was there, your sine was there. Your reciprocals, you just flip them over. Your tangent is the only one that needs a little work. So you keep, you change, you flip. And out comes that. I noticed in like the last test with the logs especially, you're catching the new concepts. What you're having trouble with are some of your old skills. Your old skills, no crossing out terms, what to do with a fraction, what do I do with a fraction, what do I do with my negatives, positives. Your old skills kind of catch you up sometimes. So make sure you practice those things. You know, when you see a complex fraction, a fraction on top of a fraction, it has to be one term before you can flip it over. You can't cancel anything out until that happens. Okay. These guys, again, all they just did through this whole exercise was just rotate them into a different quadrant. You're still your unit circle. So here's my information again. My x is my cosine. My y is my sine. Your tangent, y over x. Okay, you have to know those things that we did. Cosine, remember when we had this on your sheet? X over r. Of course, on the unit circle, since r is 1, then it's x. Sine, y over r. Tangent, y over x. And your reciprocals, you just flip them over. I think it's easier to use the numbers and then flip them rather than to say r over x. Then you just got to plug them in again. And if it helps you, I did it this way because unfortunately I had them too close to each other. But if it helps you, put them next to each other like this. Cosecant, right next to each other. So that you just take them and you take its reciprocal. It's easiest when they're right alongside each other. Questions? We're just on your unit circle. And your unit circle can have an angle that is not one of your special angles. Here's your special angles. Pi over 4, there's your 45-degree angle. On your unit circle, remember what we said. If this is how you remember your 45, and only remember it one way, 1 radical 2. If I need this guy to become 1, I have to divide it by itself. So it forces me to divide everybody by itself. I rationalize that one, but you do not have to rationalize anymore. For some odd reason, I'm always rationalizing the 45 just because I teach Algebra 2 up to this year, and it's always like, I rationalize that one. You don't have to rationalize that. A negative starts here and goes all the way around. This negative also, here, all the way around. Take this bottom number, divide this into 180. There's your reference angle. So 180 divided by 3, there's a 60-degree reference angle. Do you guys know how to find an angle real fast using the radians? Say I take this angle, 2 pi over 3. What reference angle am I going to be? What is my angle of reference? 60. So I've got a 60-degree angle somewhere. Now watch. Do you see this? This is 0, this is 180, this is 360. In radians, this is 0, this is pi, this is 2 pi, right? Here's the easiest trick. Take this denominator and put it over itself. 3 pi over 3. Double it. 6 pi over 3. Now tell me, where does 2 pi over 3 fall? Before 3 pi over 3 or after 3 pi over 3? Before. There's your reference angle right here. There's where your angle is. Put the same one on the left-hand side, double it on the right-hand side. So if I take this guy, 5 pi, let's do positive 5 pi over 3. This is 3 pi over 3. This is 6 pi over 3. If I'm looking for 5 pi over 3, what quadrant do you think it will come in? No, start, not the negative, just the positive. Who is 5 pi going to come? Is it going to come after 3 pi over 3? This is a 5. It comes after this one, right? Doesn't it come right before this one? So I'm right here in this quadrant with a 60-degree triangle. See it? Now, what if I do negative 5 pi over 3? There you go, Alicia. Where would I be now? You're first, right? You would start here and come right before the 6. You'd be there. Use those two guidelines as where should I be? Especially with the 60. A 60 only has 1 in each quadrant. It only has 1. Because if you think about it, here's 1, 2, 3, 4, 5, 6. 6 times 60 is 360. So your 60 is nice. It's only going to come in 1 in each quadrant. Your 30 is going to have 2, and then the 90. So it's like 3 of them. You always have to make, today we're going to talk reference angles, you have to make this bow tie. Okay? Now, once you find your special right triangles, you can find all your pieces. Again, make sure you give a reference box. I find this the easiest way. I never have to go back and think who's positive, who's negative. This one was the same as this one because it puts you back here. You're back to quadrant 1. Remember, your negatives start at your positive x, but they rotate clockwise. Okay? Questions? Alright, is that it on this one? One more. And again, if we take 6 into 180, that's a 30-degree angle. You're dropping 1 only because you're rotating clockwise. You got a 30-degree triangle. And since we did the unit circle, your radius had to be 1. So if I looked at my 30-degree triangle, and I said, this is the one that I know and love, 2, 1, radical 3. If I need this to be a 1, I divide everybody by 2. Works out? Could you even find it without a unit circle? You certainly could, right? And just reduce this down. They all reduce down. They all reduce down. Now, your reference angles, guys, here's the key word. It's an acute angle. Acute is what degrees? Less than 90. It's less than 90. Anything in quadrant 1 is therefore positive sine, positive cosine, positive tangent, right? So anytime we go back to your reference angle, we're looking for that little acute angle that's sat in quadrant 1. Now, let's see if we can place where this goes. First of all, what's my reference angle? How many degrees in my reference angle? 180 divided by 4. Like 4 something. 45. Just take the bottom number first for the reference angle. So 4 goes into 180 45 times. We get a 45-degree reference angle. Watch. This is over 4. So to get pi, we put the same number because don't we cancel that out when it comes to pi? We double it over here. When we do this, doesn't that come to 2 pi? We want it to be pi and 2 pi. What quadrant is this going to land in? Not 1. It's got to come past the 4. Does it go up past the 8?
Wait, it has to come. It has to go up in circle again.
It's got to start here. It's got to rotate this way. Where is my terminating side going to be? Third. Because this is 4 pi, this would be 5 pi, wouldn't it?
Oh.
It's going to come like this. This angle is 5 pi over 4. This guy would be 7 pi over 4. See how to do that the short way?
Well, when it's negative.
When it's negative, it comes the other way. Well, right now we were just trying to figure out, without converting to degrees, where is this going to land? So if you always set this up, no matter what your bottom number is, set it single here, double here, you can kind of see 3 pi over 4 would end up here in this quadrant. 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. How many 45s come into 90? 2. So I've got to go every 2. So technically I'm like this. 1, 2, 3, 4, 5, 6, 7, 8. See it? I'm setting them up like that. The fastest way to do this, because your reference angles are formed between your terminal side and your x-axis, it's got to be along here. It's going to give me a bow tie. It's got to be one of those. Picture me wearing a big red bow tie. Don't turn my bow tie this way, or I can't put my head down. So my bow tie's got to go like this. It's got to come to this horizontal axis. So we only work off of your pi and your 2 pi. Your 180, your 360. We don't use your 90 and your 270 because my bow tie wouldn't fit that way. So it's got to be one of these guys. So it's right here. This is where 5 pi over 4 is. Now, you told me this is a 45-degree angle. I don't care about your unit circle right now. It doesn't say unit circle. If it says unit circle, just like your regions did, then you have to have a radius of 1. If it doesn't say unit circle, you can put whatever radius you like. So you come here and you say, okay, I'm going to label your special 45-degree angle. This was my radical 2. This is my 1, 1. Right? Because my special triangle tells me this. 45. Isn't that my special triangle? So I put it here. Now, pull out your information. X in this quadrant, off my x-axis, is that x positive or negative? Negative. So it's negative 1. Down here, is my y negative or positive? Negative 1. My radius is always positive. It's a distance from my center to the end of my circle. So this guy, radical 2. So all I need to do now is say my reference angle is this guy. Isn't 45 between 0 and 90? Right? And that's what helps me label my triangle. Can I find all my sine, cosines, my tangents off of my x, y, and my r? Right? If I say sine, take my y, -1 over radical 2. Cosine, tangent, negative over negative. A negative over negative is what? Positive. Make sure you change that. Don't leave it negative over negative. So I take these, I take its reciprocal, negative radical 2. One over 1, still 1. Can I find all my pieces once I locate where is my reference angle? What quadrant? Take the positive value of that and make my triangle. And I take all my attributes for that guy. Make sense? If I was to reflect that into this quadrant, I would get the same x, y, and r's, but the SIG ends would be different. The x here is positive, the y here is negative, my r is always positive. So depending on what quadrant you land this triangle in, it is a congruent triangle. It's a congruent triangle that I reflect all the way around. Okay? Now, sometimes we have an angle, and all I'm asking you to do is find me a reference angle. A little angle between 0 and 90 that meets up to this axis. So what quadrant does 203 terminate in? 3. Start like this. 360 and 180. Just put them down. So now you know you go past 180. You came to 203. I need to know this little angle in here. The angle that comes between my axis and my terminal side. So I noticed I went past 180. How much past 180? I subtract it. This little angle is 23 degrees. If I had a special triangle, I could set up my special triangle. But I don't have a special triangle for this guy. So all we need to do is just figure out the reference angle. Okay? What if I gave you an angle of 291? What quadrant am I in? Fourth quadrant. Good. Because this guy right here, 270. So I come around, I stop here. I want this angle right here. I don't want this angle in here. I want this one that meets my x-axis, that gives me a bow tie. So if this is 291, look, I didn't quite make it to 360. 360 minus 291, and I subtract and get my reference angle. Make sure you use your 180s and your 360s to find your reference angle. Don't go off your 90 and your 270. Okay? Okay. Coterminals. We don't do a lot with coterminals, but just so that you know what a coterminal is. Co means how many? 2. They share. Co-pilot. The pilot and the co-pilot. They share being the pilot. A side and a coterminal. The coterminal means they share sides. Terminal is side. So they co-terminal. They cohabitate. You share where you live. Co-terminal, you share the side that it terminates. So say I give you an angle of 30 degrees. That angle goes here. I want another angle that shares the same side. So I could say, okay, let me come all the way around 360 plus another 30. What does that give me? 390. Agree? I started here. I came all the way to 360, plus I went another 30. Right? Now, Another coterminal angle could be what starts from my negative side. I start here, I come all the way around, and I terminate right there. How do you think I figure out that degrees? Negative 330. So you said 30 minus 360. Good. Very good. Because doesn't it have to meet full circle? Doesn't it have to come to 360? I made a complete circle with it. I took its positive, I took its negative, and I made a complete 360 with it. 360 minus 30 is 330, but I came from the negative side. So if you take your angle plus or minus 360, there's your rule to find a coterminal angle. I'm just kind of like touching on some of the things that you probably learned in Algebra 2, but you maybe don't remember. They kind of seemed a little bit, sounds a little weird. Alicia remembers. You got your trig stuff down, Pat, right?
That was the fun stuff.
Yeah, you know what? It's also more visual. When it comes to trig, it's very visual. And that's what kids have a little harder time with. You have to sketch, you have to visualize. It doesn't come without that part. You really have to place where your angle is to see what's going on. So if you're a visual person, this should be a lot nicer. Now, we talked about reciprocals, right? 1 over. The cosine is 1 over the cosine is your secant. 1 over your tangent is your cotangent. They're reciprocals of each other. I think you have them on your papers, right? Right? No? On the notes? Yeah. Now, your identities. Your Pythagorean identities. If you remember your Algebra 2 teacher saying, you have to know this one. This one you have to know. And this is where you get this. Let's go to your unit circle. Watch. I open up an angle, any angle. What's my radius? 1. This piece here measures my x. This piece here measures my y. Agree? So, it's a right triangle. Pythagorean theorem. X squared plus y squared equals 1. True, right? It's a right triangle. The x on your unit circle is which one? Cosine or sine? Cosine. It's alphabetical. So if I replace that and I replace your y with a sine, Pythagorean's identity. Cosine squared plus sine squared equals 1. Okay? Now, if I want to make the word tangent out of this, tangent is what in terms of sine and cosine? Y over x, and what is your y? Sine over cosine. So if I come over here and I divide this guy by cosine squared, it's an equation, so I have to divide everybody by cosine squared. So cosine squared over cosine is 1. Sine over cosine is tangent. If it's squared, it stays squared. And 1 over cosine is which one? Secant. There's your other identities. What was that? Hi, what was that? Oh, how we got this part? 1 over cosine is its reciprocal function, is your secant. They're reciprocals of each other. So if I did this, if I go back to your cosine and say x over r, then I say your secant is r over x. We just flipped them around. But that's the same as saying this, 1 over x over r. If I keep, change, flip, this becomes 1 over 1 times r over x. That's where you get your r over x from. It's really the 1 over. They're reciprocals. Now, so if I went back to my original one, how do you think I get this guy? By sine squared. Divide every term by sine squared. So you only have to remember the 1. Cosine squared plus sine squared equals 1. Okay? Okay. Now, Here's a non-unit circle. How did I know by looking at that coordinate that it was a non-unit circle? I don't know, let me think. Radius on a unit circle is what? 1. So since Pythagorean theorem says your radius, if your hypotenuse has to be the largest side, don't my x and y have to both be smaller than 1? Are they? Is 12 smaller than 1? No. Okay, we're getting somewhere. So this is a non-unit circle. What quadrant does that point exist in? 4. My x is positive, my y is negative. Here's my point. 12, negative 5. Agreed? All I'm doing now is looking, where is this point located? So now, I'm going to start my angle here. I'm going to rotate counterclockwise and end it right there. There's my terminal side. But remember my big bow tie. My bow tie comes up to the x-axis. This is my x, this is my y. So 12 and 5. X is equal to 12. Y is equal to negative 5. How am I going to find R? What kind of triangle is this? A right triangle. Ah, Pythagorean theorem. And let me give you a hint. Pythagorean theorem, whenever you're squaring negatives, never put the negative in. Because if you don't put it in parentheses, it's wrong. So side, side. This will give me 144 plus 25. And I take the square root, so what is C? 13. So, from this information box, can I make all my sine, cosine, my tangents? Right? Do I have to ever look back to see who's positive, who's negative? It's right there in front of me. Yes. Because this is the problem. If I do this, do you know how many kids put it in like this without doing this? And then it's wrong. So whenever you're squaring a negative, don't you always get a positive? So do not put the negative in when you square it.
And then how come you put a negative 5 on the graph?
Well, because I put it here. This technically is a distance from here to here. If you want to put the negative, you can. But if we reflect this, these are distances. If you'd like to keep your negative right there, you certainly can. I usually just use positives because, remember, it all comes from the quadrant 1 positive angle, and it reflects into these different quadrants. But can you get all your pieces from that? Good? Okay, let's take a look at another one. Example 2. I have a triangle, and I need to find all 6 trig functions. What am I missing here? The radius. In this case, it's not on a circle, so it's just the hypotenuse, right? How do I find this? Pythagorean theorem. 1 squared plus 2 squared equals c squared. 1 plus 4 is 5. So what is c equal to? Good. You make sure you leave it radical 5. So in this case, this is my opposite side, this is my adjacent, this is my hypotenuse. So I have an opposite of 1, an adjacent of 2, a hypotenuse of radical 5. SOHCAHTOA will give me all my functions, right? Always use your information box.
How do you switch to that and not do X and Y?
Because you didn't have a circle.
Oh,
You didn't have a circle around it. We couldn't give you an X and a Y point off of this one. Okay? What do I do to this guy? How am I going to label this triangle? In terms of SOHCAHTOA, I'm not on a circle, so I'm going to use SOHCAHTOA. What is cosine equivalent to? Adjacent over hypotenuse. This is my reference angle. Rachel, did I lose you? Where? I used I had to use SOHCAHTOA because we were not on a circle. Is that all right? opposite, adjacent, hypotenuse. So now, here's my adjacent, here's my hypotenuse. How do I find my missing side? Pythagorean. Now be careful. This time, guys, this time, which piece am I finding? Let's find B. So C is 7 squared. A is 5 squared. Does it matter if it's A or B? No, that's commutative. It doesn't matter. But what matters is you get them in the right spot. So I come here. I subtract 29, and I get B squared is equal to 24. Now, I have to reduce all radicals. Not in my calculator, but I have to say what's a perfect square, what's a not perfect square factor. Think of 24 divided by 2, divided by 3, divided by 4, 6, and 4. Perfect square, not perfect square. 2 radical 6. Good. So I've got my adjacent to be 5, my opposite to be 2 radical 6, and my hypotenuse to be 7. Can I find all my pieces from that?
Yep.
Yep. All of those are positive when you're not on a circle, guys, because they're all distances. Okay? One more example. Hang on. I think there's one more example. 2 more. Quadrant 1. I drop an angle. I'm back on my circle. Guys, give me 1 minute. I'm back on my circle. Tangent is which pieces? X, Y, in terms of X and Y. It's Y over X. So my Y is radical 3. My X is 1. What's my hypotenuse? Yeah, you do. 2. It's a special triangle. What's this angle? 60. Good. Can you find all the pieces? Good. Now, last one. Watch. If something on my number line is greater than 0, is it positive or negative? Positive. Guys, just let me finish this. So where is cosine positive? Here and here. Tangent negative. Where is tangent negative? Here and here. Where do they overlap? That's where this is. Okay, you have your homework sheet, guys.